Okay, welcome everybody. This video is on the concept of modular programming, or commonly referred to as functions. And what we're going to do is we're going to take a non-modular program and make it modular. And you will see the concepts, I think, pretty well. So here is our program, and it's using Turtle. So I didn't want to do that. So all it does is goes to a spot, it draws a square, and then it draws a circle. So first, let's just all right. So first thing about modular programming, or when you build functions, is get it to work first in main, or in a non-function mode. So I know it works. So now I am going to take the code that draws a square and make a function out of it. And I will put it above, because the concept is that I should not be able to call a function unless it's defined. So to define it, all I do is say def, D for define, the function name, and I'm going to call it draw a square. And followed by parentheses. And here will go parameters, which we don't have right now, but we will get to yet. We will get to when we can, because it's very important. And now, all I want to do is take the code that I already know is working, right? I mean, I don't want to take code that I don't think is working. I know this is working, and I am going to copy it and paste it in my code, and now inside the function. And now I have to line up everything, because in Python, this indent, of course, means that it will be part of the function draw a square. All right. So now the next thing I am going to do is I am going to comment out the code I just copied. I am not going to delete it. Not yet, because you don't want to delete code, working code, until you know that you have replacement code that works and is better. So the question is, with a replacement code, how am I going to do the same thing? Well, in terminology terms, I have to call the function draw a square. All right, because that is what I defined. And that's the name, so that's what I have to do. And to do that, all I have to do is, now, since this does not return anything, since draw a square doesn't return anything, I don't have to say something equals. But since I don't have to do that, all I have to do is say draw a square. And what will happen is Python will look for one of its own functions, one defined by Python to be draw a square, and it will not find it. So it'll say, well, okay, well, it has to be defined somewhere. Otherwise, I don't know what it is. So where is it? And it will know that I have defined it right here, and it will execute this code. So right now, all I want to do is just do this draw a square. All right, and it should come out exactly the same as it did before. And it does. Okay, so now this code that I commented out, now I'm going to get rid of it because I know that I have replacement code that does the same thing and is better because I replaced it with just draw a square. Now, first thing about draw a square is that it is, we're repeating 4 things 4. So let's create a loop for this to make it shorter. And since the object of this isn't loops, I am going to just for index in range 4, because we're going to do it 4 times. All I'm going to do is this, and I know it's going to work, so I'm just going to get rid of these. But again, we go one piece at a time. So now I save this and I run it, and it should be exactly the same as it was before. All right. So now we have modularized or made a function called draw a square. So
yeah, the Father's Day card from Ashley. It's thrown on the floor.
Oh, so all right, now that works. Now, since we know that it works, we're going to do the same thing with draw a circle. So I would say def draw a circle. And no parameters. And now what am I going to do? I am going to copy all the code that I had for drawing a circle. Right? I know it works, which is always good. And I'm going to put it here. And again, I have to line it up to say that all of these belong in draw a circle. All right. And I'm going to do what I did with the other one. I'm going to comment them out first. And call the function by saying draw a circle. Save and run. And again, it should be exactly the same. And it is. And now I can get rid of this code. All right. So next thing is I have this turtle pen up go to X. So this is a good idea to bring up the concept of parameters. Now, what are parameters? Parameters are information that a function needs to do whatever it needs to do. We do not have any parameters in draw a square. If we did, they would go between the parentheses. We don't have any parameters for draw a circle. All right. But I am going to make a function out of this go to a spot. And for that, I do need two pieces of information. I need the X and the Y. So to do this again, I am just going to define a function. I'm going to say, call it go to spot. And now, since I need these two information, which are the X coordinate, the Y coordinate, I'm going to say X coord and Y coord. Those are my parameters, right? I need those two pieces of information to do what this function is supposed to do. So I am going to copy this. I am going to put it up. And now, instead of saying negative 200, 200, or 200, negative 200, I am going to replace this, which is the X coordinate I want to go to, excuse me, this, which is the X coordinate I want to go to, with X coord, right, which is this, which is the information I needed for the X coordinate. And I'm going to replace the negative 200 with Y coord. Right? So now I can replace this with let me do it in the two places. This should be the same as saying go to spot. -200, -200, right? Because that's what this was doing. And this should be the same as go to spot 100, -100. All right. In terminology, I am calling the function go to spot. I am passing two parameters or two arguments. When you do this, right, go to spot says, okay, I need two coordinates. So when you call it, you better call it with two coordinates. It expects these to be numbers. So when you call it, they better be numbers. Now, they don't have to be numbers. They could be a variable that's a number. All right, but we're just going to use numbers for now. And so if I do this, this should again look exactly the same as it did before. And it does. And now I will get rid of my commented out code because, again, I already have code that I know works and is better. So that's the idea of parameters. Now, just to show, could I change, how would I change or put parameters in a circle or the square? Let's do the square. So instead of hard coding the 100, right, or the only thing that's variable here is how big each side is, because I have to do 4 sides, so this is okay. And I have to turn 90 degrees, so that's okay. But this size is really kind of variable, so I can make it as big or small as I want. So I'm going to call this length of side. So in other words, I want to tell you to tell me how big each side should be. And now I am going to replace that hard-coded 100 with length of side. So now when I call draw a square, I have to pass it one piece of information, the length of a side. So now when I say draw a square, this is no longer valid because draw a square now requires one parameter. And I did say 100, but let's make it bigger. Let's make it twice as big. Let's make it 200. So this should now draw a square where the length of each side was not 100 like I had hard coded before. It should be 200. And it went off the page, but they're over 200, right? So now, could I do the same thing with circle? What could I do? Well, since we're doing, we've got one to work, let's go whole hog. Let's make it pass it the F color for the fill color, the P color, pen color, the P size for the pen size, and the radius. So now I'm passing 4 parameters to draw a circle. Is there a limit? Probably, but you don't have to worry about it because you'll never hit it. So instead of hard coding red, I am going to replace that with F color, right? Because that's the color that I pass it, which is going to be the fill color. I am going to replace this hard coded blue with P color. I am going to replace the P size, or the pen size, it's hard coded 4 with P size, and replace this 100, which is the radius of the circle, with whatever I pass it. So that is radius. So now I have 4 parameters. I can pass it any different set of information that I want. So now I have to change the call. So here's draw a circle. The first parameter is my fill color. So I'm going to put, let's say, green. All right, separated by a comma, just like that. The other is a second parameter is a pen color, and I am going to say pink. The third parameter is the pen size, which is going to be generally a number between 2 and 10. I'll just say 5. And the radius, it was 100. We'll make it 50. Let's make it a smaller circle. When you do this, it is so important. When you match the calling statement to the definition of the function, the number of parameters have to be the same, right? This says I'm expecting 4 parameters. So when I call it, I have to have 4 parameters, right? It is expecting this one, the first one, to be a string, the color, the second one to be a string color, the third to be a size, which is going to be an integer, and the fourth going to be an integer, which is the radius. Although I am hard coding these here, if I could also use variables. I mean, if I wanted to make a different, I'll do that after this. But so important. The number has to match, the order has to match, and the data types have to match between the calling of a function, right, which is what I'm doing here, and the definition of the function, which I have doing right there. All right, got to match the number, the order, and the data types. So let's save this and run again. And now I had a little smaller circle. So now, what does this give us? Well, the good part is this gives us the option of doing something different. Let's copy the same thing. I'm going to do it twice. And now I am going to, after I draw the circle, I'm going to go to, well, we'll say 50, negative 50. And I'm going to, well, I don't need to draw set the turtle shape because it's already, I know it's a turtle. So, and once I go to 50, negative 50, I am going to draw a square of, let's say 100. And then I'm going to go to 75 and 75. And then I'm going to draw a square where the fill color is, instead of green, say blue. And the pen color is going to be red. Its pen size is going to be 3, and its radius is going to be 75. So first, just to show that this works, all right. And the big thing to remember is, look, I don't want to have to repeat these, 6 lines every time I draw a circle. I don't want to do my 6 lines here and my 6 lines here. And remember that, again, I mean, you could have draw a circle called from anywhere within the code, right? So it saves space. It is easier to code and manage because there's only one place where draw a circle is defined. Right? And I have the ability to use it over and over again. If I did not do this, my program would be much, much, much longer and not any better. It would be worse, in fact. But this is the concept of functions and parameters and why we use them. But now we have to do one other thing, because these are functions that are of a specific kind, meaning they do not return any values. Some people, as a matter of phraseology, would say a function that doesn't return anything is a procedure or something. They say the idea of a function is to return something. And they make a distinction between a function that doesn't return anything and a function that does return something. We are not going to make that distinction. We are just going to make it a function. But now, just to show the idea of how it returns value, because this is the other very big thing we have to understand about functions is this. Do I have a test function in here? Let's see what this is. Oh, this was the hangman game. I don't want that. So let's open here, Caesar cipher. All right. And I want you to take a look at this and look at the function, and what we got to make sure of that we do, that you understand, is this keyword return. This. Take a look at this. I'll be right back. Okay, we're back. Now, here is the idea of the Caesar cipher and the idea of functions. Now, there's only two main functions in here. One is encrypt, just for encrypt, and one is decrypt. All right. And what it does is it takes or it gets past name. Now, name is going to be a string. All right. It starts out with an encrypted string of blank or empty. For each letter in the string that I pass to it, this statement is going to get the ASCII value of it. All right. And to encrypt it, we are going to add 1 to it. So what it's going to do is just to make a little, a capital E, a capital F, a little C, a little D. That's they are the encrypted ones. All right. And the logic for the 90 is, well, if I have a Z and I bump it up by 1, it wouldn't be a letter. So we go back and make it an A. And the same thing for a capital Z. We would make it a capital A. But after it's done, the whole purpose of this for loop is to build a string, an encrypted string, which is going to be an encrypt underscore name. And then I return the value. All right. So if you look at this now, the difference is when I call encrypt or ecrypt, since it returns a value, I can't just say ecrypt parentheses or ecrypt and then parentheses the name, right? I have to say my name equals, right? Because this is going to return a value. Think about it, and it's going to evaluate something and just replace it with, and then after it does it, just replace that with a string. And you have to say something equals that string. So this returns one parameter, returns one value. And it gets stored in my names. It has one parameter, which is the string I'm going to encrypt. It returns the encrypted string, and I put it in my name. All right. I then take my name, which is encrypted, and now I go through decrypt, which takes the string that is not that is encrypted and will decrypt it back. So when it's done, these should look exactly the same. So if I run this, okay, my name unencrypted is Zebulon. My name encrypted is AFCW, whatever, PO. But then if I decrypt it again, it goes back to Zebulon. All right. So this is an example of returning one value. In our turtle program, we didn't return any value, but now we're returning one value. All right. So we have each of these. All right. So I have to say something equals this decrypted name, right? Because it's returning a value, what it returns is going to get stored in my name. Now, Python is very unusual in compared to many languages, because all languages will allow you to uh, do no values, to return no values. All right. And all functions, all programming languages will give you the option to return one value. But Python is unusual because, let's see if this is a good example. It will allow you to do more than one value. So just to do this, let's say I wanted to figure out how long the string is, right? I want to return that along with the name. All right. So now let's do this for encrypt. Let's say, and we'll start out with an empty string and we'll say num letters equals 0, right? And for every letter in name, I am going to bump the num letters by 1. Which is the same thing as saying num letters equals num letters plus 1. And now, here's what is very, very unusual about Python. I am going to say return the encrypted name and the number of letters. So now I am returning two things, two values I'm returning from the function. Again, very unusual in programming languages. So now when I call encrypt, I can't just have one value. I have to say, I'll put my name, comma, or my name, EE, comma, I'll call it letter count. Equals encrypt or encrypt my name. Because, again, my name is my name, all right, but I am returning two values. So I have to have two variables to hold these values. So now I'm going to say my name encrypted is, and my name had and the string of letter count letters, right? Because the function encrypt returned more than one value. Let's save this, run this, let's make sure that this is right. And Zebulon does have 7 letters, right? So again, this is an example of returning one value, right? Decrypt just returns the one value. So when I call it, I have to have one variable here. eCrypt returns two values, the encrypted name and the number of letters. So when I call eCrypt right here, I have to give it two variables to hold what gets returned. Question is, could you return 3 or 4 or 5 values? Yes, you could. Are you likely to do it? Probably not. All right. It's like many things that I tell people about computer programming. Just because you have the ability to do it, there's practically no chance that you will ever even approach the limit of what you can do. All right. So, very, very important. Again, the concept of it doesn't have to return a value, right? And if it doesn't return a value, I can just say, draw a square, right? I don't have to say something equals draw a square because draw a square doesn't return anything. On the other hand, I Caesar cipher, the decrypt function returns one value. The eCrypt returns two values, right? So for decrypt, I have to use, right? Since it returns one value, I only have one. But eCrypt, since it returns two, I have to have two. All right. So, big thing about functions. The things to remember about functions are this: do they return a value? And if they do, how many values do they return? And just like your input, just like the parameters, right? The number has to match, right? So these are called with one parameter. So when I call them, better have one parameter, right? What gets returned has to match. This returns two values. So in this case, I have to store them into two values. All right. In this, it is very important, again, when you call the function, right, the number of parameters has to match. The order has to match, right? I can't put, 375 blue, red here because it's expecting the first one to be the color. And the data types have to match. So it's expecting a string, a small number and a larger number, but not super big number, right? And that's what I have to have here. I hard coded these. If I wanted to, I could just say FCLR equals blue. And PCLR equals red. And I say PSZ equals 3. And let me say RDS for radius equals 7.5, right? And now, instead of doing this, because this is what we call hard coding, and it's generally not a good thing to do. Generally, we would use variables. So really, I wouldn't call it that way. I'll comment out this. And now I am going to draw a circle, but instead of these hard-coded values, I am going to use FCLR right? And PCLR and PSZ and RDS. All right. Another big thing, right? When I call this, the number, the order, data types have to match. Do the names have to match? In other words, when I call it, do I have to call it with a variable called pen color or a variable called F color, a variable called, no, I do not. These names, excuse me, these names in the parentheses, right, do not have to match these names. All right. And again, these could be hard coded, but they could be variables as long as the variables are of the right type. So just to show that this works, all right, it works exactly the same. So that's the important thing to remember about functions, which is also called modular programming. It is imperative that you understand this concept of modular program. It doesn't matter what language it is. Java, C Sharp, C++, C, every language, every single programming language, you have to understand this concept of breaking things up into modules. If you do not, you would have to put everything in main and you can only write trivial programs. So I hope this is a good tutorial and you learn something and you understand the idea of functions in Python. And I will put out some more videos if so requested. So thanks, have a good night or day, and I will see you later. Bye.